Okay, we're looking at rearranging equations here and solving for a variable, and all these we're solving just for x. To get x by itself, I need to get rid of the a. These are really straightforward. Subtract a. You can't combine a y and an a, so that's just my answer, x equals y minus a. Over here, if I have x divided by 15, I need to multiply by 15 to get rid of that. So 15y will equal just x, I got x by itself. In this one, I would need to add 2y to both sides because I need to get the x term by itself, and it's subtracting 2y. So that means ax equals, well, y and 2y, those can combine to be 3y. Then to get rid of the a here, it's a times x, so I need to divide both sides by a. X equals 3y divided by a. Okay, those are the easy ones. Now these ones require a little bit extra step, not too much. With this, to get x by itself, got a couple options actually. One thing I could do is distribute the 2 into x and a, and then we're just like we had in the last problem. Subtract 2a over, so w minus 2a, and then I would divide everything by 2, w minus 2a over 2. The other option that I could have done instead was, well, here's this whole thing, x is combined with x plus a. I could divide the whole thing by 2 right away, which would leave me x plus a would equal w divided by 2. And then I would just subtract a from both sides, and get w over 2 minus a. And that's actually the same thing, because if I took this as a hard problem and just broke it up, it would be w over 2 minus 2a over 2, which that would cancel to be just a, which is the exact same thing. In this one here, to get x by itself, get the 3y out of there first, so you get 1/2 x will equal z minus 3y. And then you're really dividing by 1/2, which means flip and multiply, you're multiplying by 2. Now make sure you multiply the entire other side by 2. So x will equal, I'll distribute that 2 in, 2z minus 6y. Okay, third page, probably the toughest one of them. To get x by itself here, well first let's get this entire x fraction by itself. So to do that, I have positive 2, I need to subtract 2 from both sides. Y minus 2 equals negative 4 over x. One thing I will say with this, I can either look at it as a proportion and cross multiply, or I can just say, well, I have x on the bottom, so I need to multiply both sides by an x. So that will cancel out my x and give me x times y minus 2 to equal negative 4. Well, now to get x by itself, I need to get the y minus 2 out of there. Well, it's one big term, so I can just divide by it, which means x will equal negative 4 over y minus 2. If I cross-multiplied, I would have had the exact same scenario work out. Let's do cross-multiplying for this one just to see it differently. Cross-multiply 1 times x minus 1 is just x minus 1. 3y times x plus 1, I'll just write it just like that. Now, to get x by itself, I have x on both sides, so that's no good. I need to try to get x all on the same side. So to do that, I'm going to go and first distribute through this. So 3yx or 3xy plus 3y. And now I'm going to get everything with an x onto the left-hand side, everything without an x on the right-hand side. So I'll get the plus 1 out of there first, and then I will subtract a 3xy from both sides. So I'll have x minus 3xy will equal, and I still have 3y plus 1 over here. Both of these terms have x. Well, that means I can factor out an x. This is the main thing people will end up missing. You got to remember to factor out that x. 1 is left behind when I factor out an x from that, and 3y is left from the second term, and that equals 3y plus 1. Now to get x by itself, just like we had up here, divide by what was left over. So x equals 3y plus 1 over 1 minus 3y. That's probably the toughest problem on this entire thing. And the last section, square roots and squaring. To get x by itself, first get x squared by itself. So a squared minus y squared. And to get rid of a square, the opposite is the square root. Square root of a squared minus y squared. Don't forget, when you put your square root in though, you need a plus or minus. Square root of 36, or if you have 36 being x squared, that means square root could be either 6 or negative 6. So don't forget about that. If it was a cubed root, and this is, or a cube and that had become a cubed root, then you don't need the plus or minus, because cubes are sign dependent. When it's just squared or fourth or any even power, you need plus or minus. This one up here, I'm going to first move the y. So the cubed root of x will equal 4 minus y. And then to get rid of a cubed root, I cubed both sides. And I'm just going to keep it just like that. 4 minus y, that quantity cubed. I don't need to simplify more than that. That is a perfectly valid, legit answer. And this last one, the x is within the square root, so square both sides first. Make sure you square the entire thing. Those cancel out, giving you x squared plus y. On the right side, 5 squared is 25. Y squared is, well, y squared. Now, subtract a y, so x squared equals 25y squared minus y. Can't combine those, y squareds and y's are different. And now square root, don't forget plus or minus because you're taking the square root yourself, 25y squared minus y.